says n times n square plus 5 is divisible by 6. So I will rewrite this question, or n times n square plus 5 is equal to 6n, where your m belongs to integers, right? So let's begin. Proof. What does step 1 says? Put n is equal to 1. So what does my LHS becomes? 1 square plus 5, that is 6. So that is divisible by 6, right? Is equal to 1. So that is equal to RHS type format, right? Where your m is 1. So hence we can say n is equal to 1 wholes. Now let's do step 2. Step 2 is assume n is equal to k wholes. We will assume n is equal to k wholes. What it gives us? That k square plus 5 is equal to some 6 alpha, where alpha belongs to C. Okay, next is your step 3. This becomes to prove n is equal to k plus 1 wholes. We need to do this. So this becomes k plus 1 whole square plus 5, and here you have k plus 1 is equal to some 6 alpha dash. Okay, so this gives us LHS is equal to k plus 1 whole square plus 5. So this becomes k plus 1. Let's expand this. It will be k square 2k plus 1 plus 5. Now let's look up. We need k square plus 5, that is equal to 6 alpha. Right? We need to club accordingly. So it's k plus 1, k square plus 5. This is 2k plus 1, right? Now it becomes k square plus 5 plus k 2k plus 1. Fine. We are multiplying k with this. Now with 1, what it will give me? K square plus 5 plus 2k plus 1, right? Now this from the assume part, right? This is your assumption. Let's label this as star. Now from star, what do you get? This is equal to 6 alpha, right? Now let's just expand these bracket. It's 2k square plus 1 plus k square plus 5 plus 2k plus 1. So this will be 6 alpha. 2k k square will be 3k square. 2k, right? There's a k and there's a k over here. So it becomes 3k, right? And then you have 6 over here. So can I, okay. So this is a multiple of 6. This is a multiple of 6. Now we need to focus on this. So this will be 6. Here you have 3k square, 3k. Now from these terms, let's pull out 3 and k. Let's see what it gives us. 6 alpha, 6, 3k, k plus 1. Okay. Now just notice these are two consecutive terms, and we know this fact that the product of two consecutive terms is always even, or is divisible by 2. Okay, so we know product of two consecutive terms, that product of two consecutive terms is divisible by by 2. Okay, you can check this out by proof by exhaustion. Let's say if I take first step or the first case, if k is equal to some um, 2u, a even number, so it will be, what will be k plus 1? It is 2u plus 1, right? So this is an even number, right? Look, this is an even, right? 2 is outside. Now in the second, what it will happen, if k is some 2u plus 1 types, so k plus 1 times k will be 2u plus 1, 2u plus 1 plus 1. This is 2u plus 1, 2u plus 2. If I pull out 2, it's 2, 2u plus 1, u plus 1, right? So hence it is even. So now from both the cases, even if k is odd number or k is an even number initially, we're gonna get this even. So can I say this will be 6 alpha 6 plus some 2 u dash type, right? Some even number, and here there is a, so can I say that 3 is there, then k plus 1 will be some 2 u dash type. So it's 6 alpha 6 6 u dash. If I pull out a 6, it will be alpha plus 1 u dash. This will be equal to, let's say this entire term is equal to alpha dash, right? That's what is required, and hence our result. So we can say this gives us n is equal to k plus 1 wholes, or we can say is true. So therefore by mathematical induction, n is equal to the given, by mathematical induction, given statement is true for all natural numbers. Okay, for all natural numbers n. So yeah, it was a kind of tricky question in the sense because we are using this result, the product of two consecutive numbers. So this is the proof.